Jai Hind everyone. I, Suvarana Mujumdar, Assistant Professor in Akgec Engineering College and Scientific Officer in ASF, welcomes you in the session on Structures in Labview. In today's section, we are going to discuss about the structures application in Labview. Labview is the laboratory virtual instrument engineering workbench, and in this we are going to use the programming language that is known as graphical language, or we can say G code. The outline of today's session is we will first discuss briefly about the Labview software, and then we are going to discuss about the various structures available in this Labview to develop an application for testing, measuring and control of any automation instruments. Then we are going to discuss in detail about the while loop and for loop and the timing VI. So initially we start with the Labview, that is a laboratory virtual instrument working bench. In this, the program which we return is stored in the form of virtual instrument, that is VIs, and each VI consists of three parts: front panel, block diagram and connector pin. The front panel is the window which is available for user interface, where we will define the input and output parameters, or we can say the control and indicators for any process. And the second part of our VIs are the block diagrams, where we define the function or the process that we are going to design. And the third part is known as connector pan. So front panel consists of input and output. Inputs are used to acquire the information or device either from hardware part or from any file, or we can manipulating the control. The output device, or you can say whenever the result is there, we have to display that result, or we have to store that result in a file, or we can output that device as a display. So we will just see how this will look in our Labview platform. So in Labview, I will open the new VI and I use the Control T to separate these two windows. So as I told you, this is the front panel and the block diagram. So in front panel, we will select all the controls and indicators, that is the input and output, and whatever the process or program we have to develop the application, that application is developed on the block diagram panel. So if we see the block diagram part, whatever we choose in the front panel, the control or indicator, the icon will be automatically connected at the block diagram part. So that icon which will be available on block diagram is known as terminals, and we will see how this will look. So we will generate one VI for, quickly we will go for determining the area of triangle. So on this panel, so if I have to find the area of a triangle, I need two inputs, one as a base and another one as a height. I will name it as base and height. So as these are the two controls which we created at the front panel, the same control will be available in the block diagram, and here we can name it as a terminal, and then we will use one indicator for the area which will display the area of a triangle. So on the front panel we will have these three things, two controls and one indicator, and at the block diagram we will use the nodes, these multiplier and we will wired it. So the formula which we are going to use to generate an area of a triangle base into height into 0.5. So this will be the appearance on our block diagram. Okay. Different data types which we will use in our Labview are, the one which we used is the numeric one, the boolean where we will have the option 0 and 1 or true or false, strings where we use character as an input, array that is a set of same data type, whether we can have an array of a numeric number, we can have an array of boolean, we can have an array of string. We will have an enum where we can define a set of inputs, like we can define a month in a year or days in a week. And we have a cluster where we have a different set of groups, like if we have to make a database, then we need numeric input also, we need boolean input also, we need string input also. So in that case we can create a cluster. So just quickly we will go and see where we find all these data types. So again I am going to the Labview panel. So in front panel you will have a control palette, and in this control palette, if I pin this control palette, you can see we have a numeric, we have a boolean, we have a string, data containers. In this data container we have array, clusters. So depending on the application we will decide which type of control or indicator we have to use. We have to keep this in mind while using a control and indicator, that same data type should be connected. It is not possible in this Labview that we can connect input as a numeric value and we can take as an output without processing. We can't directly connect a numeric control to a boolean indicator. Like if we have a round LED as an output or an indicator, then if we try to connect this, then it will show us an error. So this is not allowed, in direct connection is not allowed, so we will not connect the data types, different data types. Okay, so we have, as I told you, we have different data types, so we will just check with this so that we can use these data types in our structures part. So the basic data types, that is the numeric one, then we have a boolean. So in boolean we have a push button. For push button we have a round LED, or we can use square LED as an indicator. Then we will have a string as an input, so we have a string control, and we will have a string indicator also. Okay, these are the basic data types. I am just connecting these data types. So whatever input you will apply here, and if you run this, I will run both the cases. And this is the run command. We will run this and we will see the result, that is area. If we connect numeric to numeric, so numeric input is control is 1, it is transferred to the output. Boolean, it is on, its LED is on, and I Labview, it is transferred. If I make this switch as off, and then if I change this base value and height and run again, you can see the results. LED is off and the area is changed. Okay, so these are the basics things that we have to keep this in mind while going towards the structure part. So now there are various structures available in the Labview. These structures are used to repeat a set of instructions depending on the conditions which we are going to implement in our application part. So the first and foremost structure is the while loop. In the while loop structure, this structure is will perform its operation till a stop input is given to this while structure. So we can say if we have to perform some repeated action for infinite number of times, or we want control to be given to the user or programmer, then in that case we will use while structure, and we will give control or a stop button to the program or the user, which will stop this while loop iteration. Next structure is for loop. When we know the specific number of times we want to execute some loop, like if I have to add 10 numbers, then I know that I have to make the addition for 10 times or 9 times, then in that case I am ready to use for loop, because in that case I know the number of iteration. Next structure is the sequence structure. In case of Labview, all the things, or we can say all the operations are processed, or we can say the data flow is from right to left, but the operation, if two functions are placed parallelly, then they will perform parallel operation, and we can say processing is parallel. We will not identify which function will be performed first. So in that case, if we want specifically that in the process should be gone in a linear fashion, then we go with sequence structure, and there are two types of sequence structure available. One is flat sequence structure and another one is a stacked sequence structure. In case of flat sequence structure, we have different sequences one by one, and first sequence will be executed, then second, then third, in a so on fashion. In the drawback of flat sequence is that if a sequence is large, then in that case the memory occupied will be more. So we will go for a stacked sequence structure, in which the sequence are placed one over other, or it is something like a case structure. So the case structure is the condition or where we know that we want to perform some set of instruction with some decision making condition, that if some condition is true, then perform the other task, if condition is false, perform second task. So in that case we will go with case structure, and we will have different structures. We will define different cases whether it is true or false. Next is the event structure. We have to define event, and if that particular event is triggered, then only that particular structure will execute it, otherwise it will remain off state, or we can say in a closed state. Time structure. This is the structure is used when we have to perform some timing operation, that for particular time of operation we have to perform some task, then in that case we were going to use the time structure. In case if we have to disable some structure, that a particular set of operation we want to perform and we don't want to perform another set of operation, then we will use this diagram disable structure, and we will select that particular set of operation and we will disable that structure. Whenever we run the our VI, that particular disable structure will not execute it. The conditional disable structure is the structure which is used when some condition is satisfied, then that particular set of structure is disabled. In this particular lecture, I am going to cover on while loop structure and for loop structure in detail, and then we will compare the while loop and for loop, because in many of the application we have to use these two loop continuously. So first of all we will see the while loop. So in while loop you can see this is the form in our NI Labview. So this is a iteration, how many times this loop will be executed, whatever the program or the code we have written here, the how many times this will be executed, this I will be iteration number, and this is the conditional terminal. This conditional terminal is we have to check whether this condition is met, then this while loop will stop the execution. So we will see how this is going to done, and if we see the flow chart for this, you can see the code is there. This code will be executed first, then condition will be checked. If condition is met, then this we will stop, means Labview will stop the execution of this vi, otherwise this while loop will be executed again, means go to code and code will be executed again. So this is the flow chart, and we will see how this while loop will be working in this Labview platform. So I can open the new vi. In this new vi, first of all we have to choose the while loop. So the while loop is a function, so we will go for block diagram, and in block diagram we have a function palette. In this function palette we have a structures, we have all the structures available here: for, while, time structure, case, event, flat sequence, formula node, math script, diagram disable, conditional disable. So all these structures are available in the functional palette structure icon. So we will go with while loop, and here we will see this while loop. I is the iteration, loop iteration, and this is, when you click here you can see it's a loop condition. When I right click on this, you can see it's a condition. There are two ways. One is stop if true. So this while loop will be continuously running till we will give a true condition to this condition terminal. And if I change this to continue if true, you can see the symbol is changed, and here this will be when continue, it will be continue if it is true, otherwise it will be stop. So we will go with the idle condition, and here I will choose one function, like we can generate equal, I can use a random number generator. So we can generate a random number. So in numeric palette, I will found this random number generator, and I will connect this random number generator to equal sign, and I connect a constant here. I can give this value 50, and I connect this to, you can see how this random number generator will behave. For this we can go to help, and we will check for this random number generator, and you can find this, the number which is generated from this is from 0 to 1. Okay, so and I am going to compare it with 50. So I need some value so that it can be in between 50. So how I can do this? I can multiply this output of random generator. I need a multiplier here, so that I can range its value from, instead of directly comparing it with make its range from 0 to 100. Okay, so we will see, we will use one indicator also here, which will give the output here, and this will give the condition. So if I run this, you can see this while loop is running, it is not stopped. It will stop only when we have this condition. It met with the condition that it will found a 50 here, but here we can see that it will not found this value. The condition, the reason behind this is that we are using here the floating point representation, and here also we are having the floating point. So the constant which we are going to use here, it will be, if we change it to numeric, that is the I32 representation, then it will work. You can change it to I32. You can see that if we run it, it will be run till infinite time because the condition is not met. But if I want to terminate this, you can see here, if I want this to be terminate, I have to add one stop button. So this is running, and if I press this, then it will stop. So we will see something more about while loop. So as I told you that this is the iteration terminal, then it is a stop if true, and there is another conditional terminal, that's continue if true. So we have two options, one stop if true and another one is continue if true. Then we found that whatever the result, the random number generated, it is displayed there. So if I have to display here, you can see here it is a tunnel, means my input or constant value. This is the constant term which is outside the loop. So if anything is outside the loop and we want to give that as a value or input to the some function which is inside the loop, then in that case we need a tunnel to transfer a data in or out of a structure. In any structure we have to create this tunnel, otherwise the data will not be transferred to the function inside the structure. So tunnel has to be created, and this tunnel will get the color of the data type with which it is connected. So whenever we connect other data, the data will be transferred to this loop only when this loop is terminated. So whenever we have to pass, we have to use this. So we will check this also in our VI. In this case, if I place this random number at generator at outside the loop, you can see a tunnel is created, and if you right click on this, you can see this tunnel is there. Okay, just one second. This is a loop tunnel. Okay, so if I place this outside, you can see now if I run this, you can see this, in this case it will run only one time and it will stop. It will not wait for this. Again I can tell you this. Why? Because in this case the value of this random number generator, we will see here, create an indicator. Okay. So you can see this is number from 0 to 1. It will generate one value, that is 0.65. This value is given to the loop after execution. Okay, so it will be executed because this boolean function is true in all the cases. So first it is executed once, one value is going to be inside and it will stop. So if I stop this, now you can see again it will take one value and go inside and stop. It can't take another value. It's running continuously, but it can't take another value. Once I make it stop and then again I run, then in that case it will take the second value. So in case of while loop, if the data is outside the loop, then the data will be inserted only when the execution is stopped. Otherwise the data will, if you change this data outside, it will not reflect that data inside the function, inside the structure. This is the drawback of while loop. In case if we are going to check an error in while loop, then this error, if error occurs, then also we will stop that particular function to be executed. So to stop the while loop, we will also go for error checking. So this is again another way to terminate the while loop, that if we simulate a signal, sine signal, and we are using this vi, express vi, to generate a simulate signal, sine signal, and an error occur, then in that case, if this error occur, then also we can stop the execution of while loop structure. Another way is we will have a stop button at the front panel. So there are two ways to stop this while loop. We are using, that's why we are using their OR gate, and that either of these two conditions will be satisfied. So any of these two conditions will be satisfied after the loop will stop. The next structure is the for loop. In the for loop, we are going to have again a loop iteration terminal I, and we have a n, that is the number of iteration, or we can say the number of times this for loop will be executed. We know the number or iteration time. So if n is fixed 100, then I will start with 0. In case of while loop also I will start with 0, and I will be checked with the condition whether I is equals to n or not. If this condition is false, then only the code will be executed. Otherwise, if condition met, the loop will stop execution. So we will see how this is going to work in our Labview. So on the same vi, I am selecting this, and I don't want to use this for while loop. I have to use for loop. So I am using a structure name as diagram disable structure, and I am disabling this. So now this structure is disabled, and now I am creating a new structure, that is for loop. Here you can see this is a loop iteration, and n is the loop count. So if I give this indicator, and I connect this with a constant, or we can right now we will change it to control. So the user will select how many times this iteration to be takes place. So I will name it as iteration number of iteration. So this is the input, and this is my loop iteration. So you can see if I give here the number 10, it will be executed 9 times. 0 is the first iteration number, so 0 to 9 there are 10 iterations. But you can see here we can't see, or I can say if I say here 100, it will give 99. So within a fraction of time this iteration will be completed, because it takes the processing time as a speed of our system. Now if I have to visualize this, whether the iteration is going on with speed, I have to add some VIs, or we have to make some delay, we have to insert some delay in this loop, so that we can visualize how this process is going on. There is another way we can make this visualize. I can use the highlight mode, and then I can run, and in that case you can see here 2, 3, 4, 5, I is varying the value. Here also you can see the change, and the loop iteration is going on in slow motion. highlight mode, that is 17. It will go up to 99. I will stop here only, otherwise it will take some time. 25, 26. So you can see the iteration. Now in this case, if we want to execute this 100 times, we know the number of times this iteration is fixed. In that case, we will go with the constant term, and we will create a constant, and we will give a value 10, and then we will run this. It will start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it will stop. So we will create a for loop with the same way as our while loop we have created. There is another option, we can replace while loop with the for loop, and we will see the random number generator, this scheme again in our while loop also. So we can just check with while loop also, for loop also, sorry. So we can generate random number here again. And we will display this random number. It will display for loop. Okay, and this is the number display for while loop. Now I can okay, so this is way, if we run this, you can see here first iteration, second iteration, third iteration, fourth iteration. The for loop is giving, as we are going with highlight mode, we are having the value, different values. And if I place this outside the for loop, again a tunnel is created, and if I make this tunnel as a indexing, it's right now it is taking the last value, and if I make it as indexing, and in that case I have to change this to array, and I have to connect it with indicator. So here the array will be created, and this array will hold the values. All the 10 values will be available in this array. You can see. So all the 10 values will be available in this array. So in case of for loop, we can convert, or we can store all the result in the array using this tunnel. We will convert this tunnel into an indexing mode, auto indexing. So all the values, if we go with the last value, then in that case only the last iteration value will be available for display. If we compare the for loop and while loop, the for loop will be executed at set number of time unless a conditional terminal is added. So if we add a conditional terminal in for loop, then we can stop the for loop in between the execution. Like if I have selected for loop for 10 execution, 10 iteration, and if I add a conditional terminal in between in my for loop, then I can stop my execution in between. If I want for loop to be executed, then I can stop, but otherwise the for loop will be executed for 10 iteration. We cannot execute zero time, means or we can say for loop will not be executed single if your iteration is 0, and is 0, then it can't be executed the code single time. And tunnels automatically output an array of data. So in case of for loop, we will have a data in an array form, that we will have all the iteration values if we choose for loop in our program. Well, in case of while loop, it stop executing only if the value at the conditional terminal is satisfied or meets the condition. Like if we go for stop if true, so if we give a command true, then only the while loop iteration will stop, otherwise it will executed for infinite time. And in case of while loop, the code will be executed at least one, while in case of for loop, condition is not met, the code will not be executed. But in case of while loop, at least once a code will be executed. And in case of while loop, only tunnel will give us the last value at the output. So depending on the application, we will choose whether we are going for loop structure or while loop structure. Just one more code and we will see the difference. I will choose a new VI so that we can have the comparison of these two. So I will choose for while loop and I will choose for loop also, and we will run both the loops and we will see the result. So here for this I will go to generate a sinusoidal waveform. We will get it with sin x. For x I am using iteration and I am using here again, so I will copy this, I can place this here. And we will use two charts, one for while loop and another for loop. Okay, so if I have given zero value here, let's start with this. Here it is saying this as a broken VI because I have not connected control here. So I have connected the control, I got the stop button. So whenever I have to stop while loop, I have to use this stop button. Now I run my VI. You can see while loop is running. We have no output at the for loop. And if I stop it, for loop will be stopped. While loop will be stopped. The condition is that I is equals to 0, and the for first case only the n is equals to I, and this will not this code is not executed. So if I make it 10 and now I can run this code, you can see it is executing, but again this is executing for infinite times because I am not pressing the stop button. Continuous if true, so it's continuousing, and it will stop only when I give this stop as a true value. But it will, this for loop is stop after 100 iteration, 10 iteration, and if I stop this, you can see I can make it 100, and you can see this. So I got 9 to 109. This is the 100, and it is going on. Again I stop this. If I place this outside, this tunnel is created. I place this outside, again a tunnel is created. Now if I run this, this is fixed, no change in the value, because the last value is there, 10 to 110. But if I change this, I stop this, and then I make it indexing. Then if we run this, in case of for loop we have 0 to 100, but in case of while loop we can't get output, and it is so showing that this untitled was stopped at while loop on the block diagram because its memory uses topic Labview. As here this running infinite time, the error occurred, memory is not utilized properly. So I have to stop this, means if I run this, I have to stop this, then it gives me the last value. So you can see here for while loop, whether I am giving it as a auto indexing or not, it will always give me a last value. But if I place this inside, then in that case it will give me a continuous value. So now it depends all on your application, for which domain you are going to generate the application. You have to choose the for loop and while loop. In case of for loop, the number of iteration which we are going to use, it should be in integer form only. Otherwise it will be converted using Korean dot method, and that is not, we have to avoid this practice, and we have to choose proper matching data type while using with for loop. To execute a VI with some delay, we will use a timing VI, and we will introduce this timing VI in our for loop or while loop so that we can see the iteration process. And there are three different waits function which we can use depending on our application, that wait millisecond, wait until next millisecond, or time elapsed time. The comparison between wait millisecond and wait until next millisecond is that if wait is 50 millisecond and the execution time is 100 millisecond, then in case of wait millisecond, total iteration time will be 150 millisecond. But in case of wait until next millisecond multiple, we have only 100, because 50 will be exhausted in the total duration time only. So in this way we can, depending on our application, we can introduce a delay in for loop and while loop. If we have to use elapsed time express VI, we can use in this, so that we can determine how much time VI will utilize while performing a particular task. Thank you. In the next session we will study about different other different structures which are right now not covered in this particular session. For more information, or if you have to do some Labview training session, then you can contact us through email ID or through website. Thank you. Have a nice day. Happy learning.